is we're going to cover the independent samples t-test. So this is the first of a 30-day workshop, okay? So we're going to cover the independent samples t-test. We're going to start with a conceptual overview of the independent samples t-test. We're going to go into how to formulate the research questions and null hypotheses. We're going to go into how to enter data for this particular test, how to test the assumptions of the independent samples t-test, including homogeneity of variance and normality. We're also going to review how to perform the independent samples t-test, how to interpret the independent samples t-test, and how to report the results of an independent samples t-test in APA format, okay? Now, so let's start with a conceptual overview. So the independent samples t-test is used when you want to compare mean scores between two groups, only two groups, okay? So in this example, we have a situation where we want to compare the average education level between males and females. Now, so we've got two variables, okay? We have a grouping variable, and then we have a continuous variable or a measurement variable. The grouping variable in this case is gender, okay? And gender is identified using what we call a nominal variable. In other words, it's identified using numbers, and we'll get into that later. But suffice to say that we have two groups in this one independent variable, right? So these two groups are independent of each other. This is females and this is males. So we call this the independent variable. The dependent variable is the average education level, okay? The average education level, because average education level we have for males and we have it for females, okay? And this is what we call a between groups design, because we're trying to examine the differences between the two groups, okay? So we call this a between groups design because they're two separate groups. Now, research question structure. Generally, the structure for the independent samples t-test is there a difference in some measure between group 1 and group 2? So the red indicates the dependent variable or the continuous variable. The blue indicates the groups of the independent variable, all right? So that's the framework. So in real terms, an example would be, is there a difference in average education level, right? Because it's red to align with some measure, because it is the dependent continuous variable. And then you have between the two groups, males and females, right? So that's the independent or the grouping variable. All right. Now, another way of structuring this question or the research question for this group is there a name of variable effect on some measure, right? So name of variable is going to be the name of the grouping variable. That's why it's in blue. And then some measure is going to be the dependent variable, which is in red. So an actual example would be, is there a gender effect on average education level? Okay, on average education level. All right, so is everyone following this? Okay, does anyone have any questions on this so far? If you have a question, type in a 1. If you do not have a question, type in a 0. Okay, all right. So the null hypothesis for the independent samples t-test is as follows. Now, null means no, right? So anytime you hear the word null, it means no. So there are no differences, right? So the null hypothesis is always going to indicate that there are no differences between groups. So specifically, the null hypothesis says there is no significant difference in average education level between males and females. That is essentially what we are testing, okay? we're testing the null hypothesis. You have the alternative hypothesis. There is a significant difference in average education level between males and females. Okay, that is the alternative, but the emphasis and the focus is on the null hypothesis. All right, so the requirements. So here's what is required to run an independent samples t-test. You have one independent variable that is categorical, either nominal or ordinal, and contains two groups. It can't contain any more than two groups, okay? Two, it has one dependent variable that is continuous. It's measured on an interval or ratio scale. Now, if you don't know what those things are, I sent out some emails earlier in the week that cover these specific items, okay? So in those emails, I sent what I call pre-workshop videos, and they cover levels of measurement and types of variables. So they're two different variables. One talks about variables and one talks about level of measurement, okay? Now, the statistical test, independent sample t-test, has two assumptions. One assumption is the test of normality, or it assumes that the distribution of the dependent variable is relatively normal for both groups. Okay, so that means that the distribution should have a bell-shaped curve for both males and females, and we'll get into that visually once we test that. And essentially, what we're going to use is the Shapiro-Wilk test, Kolmogorov test. Specifically, it's the Shapiro-Wilk test because that's a more robust test and it has greater statistical power. And then also the test of homogeneity of variance, Levine's test of homogeneity of variance. So the variance is essentially the spread of the data, okay? So essentially what you want is you want the two groups to have similar variances. So in other words, the spread of the distribution needs to be roughly the same size. So in other words, you don't want one group to have a distribution that's this wide and then another group to have a distribution that's this wide, because it's going to be very difficult to compare them theoretically. Okay. All right. So now let's go and look at the actual data. All right. So let's go and actually look at the data. Hi, this is Jacob Mays. I just want to say thank you for watching this workshop video from day one of my data analysis workshop, how to perform independent samples t-test using SPSS. There are 14 other workshops that cover all of these specific statistical tests. So if you're interested in gaining access to the workshops or the workshop series, just click on the Learn More button, and it will tell you what you need to do, what the fees are, and so on and so forth. Okay? All right, so let's get back to the video. All right. So here, if you can see my screen, type in a 1. Okay, if you can see my screen, just type in a 1. All right. Unfortunately, I did not. Those emails you have just mentioned. Okay. All right, I'll figure it out. I'll figure it out. All right, great. So essentially, the variables that we're dealing with are sex and education. This one. Matter of fact, let me just move them closer together. So I'm just going to delete them. I'm just going to clear them temporarily so that they're both next to each other. All right. So here, let me just give you the values. So sex is female and male, and then age are not age, it's education level. So education level is the number of years of education that you have completed. Okay. So we've got sex and education level. Now, right now we're looking at the value labels, right? So these are the labels, but what we want to do is we want to look at the numbers, all right? So essentially the numbers are as follows. So this is the data view. If we go to the variable view and we look up sex, we see that under values, 1 is male and 2 is female. Okay, 1 is male and 2 is female. Now, these are what we call nominal scaled variables, where the numbers are simply names or labels. So males is currently 1, but it could be 0, it could be 100, it could be 1,000. It doesn't matter because it's just a label. It has no numeric significance except to assign to males. Okay, same thing for females. You know, females could be 1, males could be 0, males could be 1,000, females could be 2,000. It doesn't matter because, again, in this scenario, the numbers are simply labels. Okay, so in this specific example, 1 is male, 2 is female. All right, now for education, education is a continuous variable. It's simply the number of years that you've completed education. And we call this a ratio variable because there is an absolute 0. You can have 0 years of completed education, okay? So these are the two variables that we're looking at. This is the independent variable because it is the grouping or categorical variable, and this is the continuous variable, the measurement variable, which is dependent, okay? All right, so the first thing we want to do is we just want to check the variables and make sure they are what we say they are, that there are no real errors. So we go to analyze, we go to descriptives, and we go to frequencies. Okay? Analyze, descriptives, and frequencies. And all we're doing is just moving these two variables over to make sure that, there are no real problems. Now, you can press OK, but we use the syntax editor, right? We always use the syntax editor because the syntax editor is a written record of everything that we've done, okay? It's a written record of everything that we've done. So we're going to highlight this and we're going to run it. And then we see here that there are 636 males, 881 females, and there are no other groups here, so that's fine. And then we also see in our distribution, frequency distribution, we see that there are 2 persons who have 0 education, 0 years of education. We've got 30 people who have completed 20 years of education. We've got 194 people who've completed 16 years of education. And we've got 175 people who've completed 14 years of education. We have 461 people who've completed 12 years of education. Okay, so this just gives us a frequency distribution, and it lets us know if there are any errors, right? So for example, if we would have seen one of these that said 100, then we would know that that's a problem because there's no way that, someone could complete 100 years of education, of formal education, okay? All right, so then we're good here, all right? So we're just gonna minimize this. Now, what we wanna do, the next thing we wanna do, and this is going to be on the worksheet that I was trying to send you, okay? So this is our little cheat sheet that I created. Oh, no, this is not it. So the cheat sheet that I created, right? So the cheat sheet is just an overview and the steps. So step 1, performing the test of normality. It's optional. And the reason why it's optional is because the central limit theorem says that if your sample size are reasonably large, 30 or more, then the distribution of sample means will be relatively normal. So even if you see that your data is not normal, because of the central limit theorem and the power of the independent samples t-test, you can still run the independent samples t-test if you have violations in normality, okay? And you can see that in any textbook. I have some references down here. I've got Cohen down here for statistical power. I'll also throw in another one really quickly. You can look at Andy Field's book. It has that in there as well about the statistical power. Okay, so now we're going to do step one or stage one, performing the test of normality. So we open the data file and we go according to this, right? It says click. Let me just move this further down a little bit. It says analyze descriptive statistics, explore. Analyze descriptive statistics and then down to explore. Okay? All right. Then what we're going to do, dependence list. Now we know that education is our dependent variable. It's our dependent continuous variable. So we put that there. And we put our categorical independent variable into the factor list. Okay? We put that into the factor list. Then, based on this, it says move your continuous dependent variable to dependence box, move your categorical independence to the factor list, and so on and so forth. Then it says click plots and then go to box plots. Okay, so then we're going to click on plots, and then we're going to make sure that factor levels together is checked. We're going to uncheck under descriptives, we're going to uncheck STEM, and we're going to click histogram. Okay, then we're going to go to normality plots with test, and we're going to click that, and then everything else we're just going to leave as is. Okay, click continue, and then we're going to click paste. Again, this is a written record of everything we've done. So we've got the frequencies here, and now we've got the test of normality. All right, so now let's examine this. All right, so this is just some descriptive statistics here, right? So we have 633 males, 877 females, 3 were missing. That counts for, these 3 account for a fifth of a percent. This one, 4 are missing, that counts for a half of a percent. Again, this is a half of a percent. And 633 accounts for 99.5% of the total sample for males, and 877 accounts for 99.5 for females. Okay, and this is just descriptive statistic stuff here. We don't need that. What we're interested in is this table right here. Okay, the test of normality. All right, and specifically we're interested in the Shapiro-Wilk. Okay, now according to this, this is essentially asking us a simple question. Is there a significant difference in the distribution of education scores for males between the normal distribution and the distribution of males? So in other words, how well does the distribution of males compare to the normal distribution, the bell curve? Same thing for females. How well does the distribution of females' scores on highest education compare to the normal distribution? Okay, and according to this, because it's less than 0.05, so let's see, 0.05 or less, it means that there's a difference between the normal distribution or the bell curve and the distribution of males and females, normal and males and females. So let's take a look at this and see what this means visually, okay? Because this is less than 0.05 and this is less than 0.05. So that means there's a significant difference in the shape, right? All right, so let's go and take a look at what this looks like. So here, the normal distribution, this is the distribution of years of education for males. This is what the normal distribution should look like. It should go up, and then it should come down like this. Now, if you look at this, would you say that the distributions are similar or different? If you think they're different, type in a D. If you think they're similar, type in an S. Okay, so this one goes like this. So the normal distribution is a bell-shaped curve, all right? This one goes like this. So would you say that they're similar or different? They're different, right? Because this distribution that is outlined in blue doesn't look anything like the one outlined in red, right? So that's why we got a p-value of less than 0.05, because there is a significant difference in the shape of the distribution, right? This one is a bell, and this one goes up and then comes down and then goes down over here and so on and so forth. So that's why we had a value of less than 0.05, right? So that's why we had a significant difference here between the bell-shaped curve and the distribution for males. So now let's look at females. Let's do the same thing. Let's draw a bell-shaped curve. Right? So a bell-shaped curve versus this distribution, which goes up, comes down, and goes like that. So what we see in blue is very different from the bell-shaped curve that we would see here, right? This is a very different kind of curve than the bell-shaped curve in red. That's why we got a p-value of less than 0.05. So there is a difference. So in other words, we have violated the assumption of normality. This distribution for females is non-normal. It does not fit the bell-shaped curve, because if it did, then this tall thing right here would be around here, and then these other scores would be around here and would form a nice bell-shaped curve. But it doesn't do that, okay? So we have a violation of normality for both males and females. And we see that here in these two numbers because they're both less than 0.05. Does that make sense? If that makes sense, could we possibly consider removing the spike? They would then be similar. Well, you can't remove the spike because that's the data, right? So if you look here, right, you can't remove the spike because the spike is actually the data. So let's go here. So when we looked at this, we saw that the spike was really representing those who were in the 12th grade, right? So if we look, these are the grades at the bottom. So this is the 12th grade. So these are the number of people who are in, you know, well, this is the number of people just for males, and this is the number of people just for females, okay? What we see up here was the total number. So we can't remove the spike because then we'd have to delete all the data. So you can't, you don't want to do that, right? So to delete the spike would mean that you'd have to delete data, and you don't want to do that. You have to, the purpose of this is to examine the data, right? We can't remove this because this simply reflects the number of people who have met this criterion, or the number of people who are in the 12th grade. So this is 10, 11, 12, 13, 14, 15. So these are 12th graders, right? So we can't remove, we wouldn't want to remove all the 12th graders from the data, right? Does that make sense? Okay, great, great, great. All right. So yeah, right. But you're right though. If we did remove, if the range of scores wasn't high for 12th, it would be closer, right? It would be closer, but even not to a degree. So let me explain. So let's say we've got, right? So this would be the bell. So let's say this came down to here, right? So let's say we brought this down here. Let's say we removed the data. You would still have a very interesting distribution. It still wouldn't match. It would be closer in a match, but it still wouldn't match the bell-shaped curve because the distribution is more skewed to the right. Does that make sense? Okay. All right. And then let's see if we go down here, again, we still have that distribution that's skewed more to the right. So even if we were to have the bell-shaped curve, that's not the best bell-shaped curve. That's awful. But anyway, you get the point, right? So you come up here, come down, and then you'd have this one here, and let's say this come down, it would still, this one's a little closer, but it's still a little bit off. But we would have to see. We still have to see. Okay, so now we've got that. So now another thing I want to talk to you about is what we call homogeneity of variance. It's the spread of the data. So now this was the distribution of scores, all right? So now we're looking at homogeneity of variance. And homogeneity of variance is essentially the spread of the data, all right? So here, so from here, get back here. So this is the 25th percentile, and this is the 75th percentile, right? This is the 25th percentile, and this is the 75th percentile, okay? Now, the assumption of homogeneity of variance. Homogeneity means the same. Homogeneous means the same. So the assumption of the independent samples t-test is that the spread of the data from lowest to highest is roughly the same, okay? But as you can see here, these are very different. So you got this one, 25 percentile here, and then you got this one starting here. And then this one for the males is way up here and way down here for the females. So the line, so the spread of the data is different. Do you see that? Does that make sense? The spread of the data is not similar for males and females, okay? The spread of the data is not similar. So when we actually run the test of homogeneity of variance, we're going to see that there's a violation because the spread of the data, there are sizable differences in the spread of the data. Does that make sense? Okay. Does anyone have any questions at this point? If you have a question, type in a 1. If you do not have a question, type in a 0. Okay. All right, great. All right, great. All right. So now, all right. So now, based on our cheat sheet, the next thing we want to do is we're going to perform the independent samples t-test. All right. So it says, so you can use this cheat sheet. So it says analyze, compare means, and then independent samples. All right. So here's what we do. we go to Analyze, Compare Means, and then Independent Samples t-test. Okay? Then what we're going to do is we're going to move our independent variable into the grouping variables box. Now, here we have to identify the groups, right? We have to tell SPSS what the males are and what the females are. So we know that 1 is male, 2 is female. So we go here, we click on Define Groups, and we type in group 1 is 1 and group 2 is 2. So whatever number you use to identify your groups, those are the 2 numbers that you need to put in here. Does that make sense? Okay, great. All right. Now, so that's our grouping variable. Now we put in our dependent variable, which is education level or number of years completed, okay? And we put that into this box right here. Click on Options, make sure this is on 95, make sure this is Exclude Cases Analysis by Analysis. We click Continue, and then again, we click Paste, right? And again, we go to our syntax and we have a written record of everything that we've done. And the reason why the syntax is so great is when you're running analysis and you've been working on this for an hour or so and you have all these different analysis, if you ever make a mistake and you have to go back to a previous version of your data, you don't have to rerun everything. You just simply highlight and then run, and everything takes you back to where you were, right? So that's why it's always good to have a written record of everything you've done. All right, so now we're going to highlight this and run it. And here we've got the number of males, number of females, the mean number of years completed for males, and the mean number of years completed for females, as well as the standard deviation for males and standard deviation for males. Now, the first thing we're going to do is we're going to look at this box of information right here. Okay? This is the test of homogeneity of variance, right? If your sig value right here is less than 0.05, that means that the spread of the data between males and females, or your 2 groups, is significantly different, right? The spread of your data is significantly different. And we already saw that the spread of the data was significantly different, right? Remember this? 25th percentile here, 75th percentile here, 25th percentile here, 75th percentile here. So that's why we saw that there was a significant difference in the spread of the data. Does that make sense? Okay, great, great. All right. So now, because this is less than 0.05, we're going to use all the data in the bottom row. Okay? So we're going to use the data in this row right here. Equal variances not assumed. Okay? Equal variances not assumed. If this was greater than 0.05, then we would use the top, right? We would use the top. So you have to remember that. And I've written that on the sheet, on the cheat sheet. I've written that on the cheat sheet. Okay? So now that we determine which one we need to use, we say, okay, let's look at the t-value. It's 3.824. It's we got the degrees of freedom here, but what we're really interested in is this, because this is going to tell us if there's a significant difference between the 2 groups. And because this is less than 0.05, this is the p-value, right? Anytime you see sig, that means p-value. And because this is less than 0.05, that means there is a statistically significant difference between the average number of years completed for school between males and females. Okay? This is what this means. So this is how we actually perform and interpret the independent samples t-test. Does that make sense? Does anyone have any questions? So first we start here. So we say 1, and then we go to 2 over here. Right? Step one is you figure out what Levine's test of equality of variance is saying by going here. And then after you determine where you should use the top or the bottom numbers, then you go over here to step 2 and you look at the p-value here, right? So this is a p-value and that's a p-value. So you look at the p-value for Levine's test, and then you look at the p-value for the independent samples t-test. Does that make sense? Okay, great. Great. Now, because this is less than 0.05, that means that there's a significant difference between the highest years of school completed between males and females. All right. So now that we know this, the next thing for us to do is to go and write the results. Okay. All right. So let me just clear this. All right. So to write the results, right, on our cheat sheet, this says this on our cheat sheet. So to write the results, we have to answer a couple of questions. All right. So these are the questions that you have to answer in order to write good results. First thing you're going to say is what test was performed and why. That's the first thing you're going to write in your report. The second thing is you're going to define your dependent variable and describe how it was measured. The third thing you're going to do is define your independent variable and describe how it was measured. The fourth thing is you're going to state the results of the test of normality, state the results of Levine's test of homogeneity of variance. And then you're going to state the results of the independent samples t-test, including the test statistic, degrees of freedom, p-value, and effect size. Then you're going to state the interpretation of results and using the mean scores, and then you're going to interpret the effect size. Now that you have done statistical significance, the second thing that you want to do is you want to test the practical significance, right? So the statistical significance basically tells you if there's a difference in the mean scores, but it doesn't tell you how large the difference is, okay? The effect size is what is going to tell you the size or the magnitude of the difference, okay? The effect size is going to tell you that. Now, in the folder that you're going to get, or that you should have gotten, but I'm going to make sure you get, there is here an effect size calculator. Okay? There is an effect size calculator. All right? And what we're going to do is we are going to calculate the effect size based on the results. Now, we're using the results for the t-value, right? So we're using the results here. All right. So the t-value is 1276.454. 1276.454. All right. Now we're going to put in the sample sizes for group 1 and group 2. So according to this, males is 633, so we're going to put in 633. And then females is 877. Type enter. Oh, I'm sorry, that wasn't, that was the degrees of freedom. It's 3.824. I'm sorry. 3.824 is the t-value. So it's 3.824. All right, because I was looking at the number. It's like, well, that's a strange number. All right, so we always round to the second decimal place, right? So we always round to the second decimal place. So basically what this tells us, let me just move this over a little bit. I just want to center this. All right, so basically what this tells us is that we have a Cohen's d effect size measure of 0.199 or 0.20. And 0.20 falls right here, right? So make that a little bit bold. So that means that the magnitude of the difference between the magnitude of the difference between 13.23 and 12.63 is small. Okay, the magnitude of the difference, and we see that right there. That's a pretty small difference between the two scores. Now, let's say, for example, the magnitude was, let's see, the effect size, let's say instead of 1263 and 1323, let's say this one was, maybe it was 20. Then we would expect our effect size to be larger because the magnitude of the differences would be larger. So the magnitude of the difference is simply the highest number minus the small number. So this one, if we subtract those, we get, let's see, 1323 minus 1263. That's only 0.6. So that's small. So Cohen's effect size measure is telling us that the magnitude of the difference, even though it's statistically significant, is small. It's less than 1 point. So according to this, it's a small effect, right? So in other words, gender has a small effect on education level, okay? Gender has a small effect on education level. All right, so we know that that's 0.20. So let's go back and talk about all right. So we say, what test was performed and why? An independent samples t-test was conducted to determine if there were significant gender differences in education level. Okay, so that's number one, right? So we're gonna highlight that. Where's the highlighter? That's fine. That's fine. That's fine. All right. All right. So we're just gonna highlight that. Right. So that's where we did that. All right. Next one, define your dependent variable and describe how it was measured. So education level was measured using an interval scale where each number represented the completed years of education. Right? So that's what we did. That's number 2. Okay, then it says define your independent variable and describe how it was measured. Gender was a nominal variable where 1 represented males and 2 represented females. Okay. Oh, it doesn't stay with me. Okay, anyway. All right. And then the next thing it says, state the results of test of normality. It says the Shapiro-Wilk test was performed to evaluate the assumption of normality. The results indicated that the distribution of education level scores were non-normal for both males and females, right? Because remember, we saw that when we saw the bell-shaped curve for both of those didn't fit because it was very tall, and then it was it had some scores that were distributed to the right. That's why it didn't fit the bell-shaped curve. All right. And then Levine's test says state the results of Levine's test. Levine's test of homogeneity of variance was significant. And we have the F value there, and that came from here, right? So we have the F value 11.23. You round to the second decimal places, and then you have a P value of P equals 0.001, okay? Indicating that the assumption of homogeneity of variance was violated. Given the central limit theorem, which states that the samples that are reasonably large will have distributions of sample means that are normal, the independent sample test, t-test, was performed. So basically all you're saying is look, even though we had a violation of homogeneity of variance, even though we had a violation of normality, we're not going to run some non-parametric test. We don't need to do that because the central limit theorem says, look, as long as your sample sizes are 30 or higher, you don't have to worry about, violations of these assumptions because the test is going to be robust and the distributions are going to be relatively normal. Even if they don't look normal, the distribution of sample means is going to be normal. Does that make sense? Okay. If that makes sense, type in a 1. If it doesn't make sense, type in a 0, and I will try to explain it differently. Okay, great, great. All right. So now we talk about the results of the t-test. So the t-test was statistically significant. So you have the t-value, you have the degrees of freedom, right? This was the degrees of freedom that we use because it was at the bottom, right? Because this was, anytime you have this less than 0.05, you use the scores at the bottom. Now, so whenever you have 4 values to the left of the decimal point, you don't have to report the numbers after the decimal point, okay? Whenever you have 4 or more values to the left of the decimal, you don't have to write the other ones. So our degrees of freedom was 1276, and our p-value was p equals less than 0.001. Whenever you see this p, this 000, that means you write it as p is less than 0.001, like I've done here. Okay? Just like I've done here. And then we've got Cohen's D, and it was 0.20, right? So then you write it in plain English. The results indicated that males, mean 13.23, standard deviation 3.14, had significantly higher levels of completed education than females, mean 1263, standard deviation 2.84. Based on the results of Cohen's D, right? Because then you have to talk about the effect size. You talked about statistical significance. Now you have to talk about practical significance, which is how big was the difference anyway? Okay, yes, they were significant, but how big was the difference? So you're looking at statistical significance and practical significance, right? Because something could be statistically significant, but the differences are so small. It's like, okay, but in the real world, I mean, it's less than one grade level apart. So it's, I mean, yes, it's statistically significant, but in the real world, it's really not, So that's why you look at both, okay? All right. So based on the result of Cohen's D, the magnitude of the differences in the means was small. And then this is the reference that you would use, Cohen 1988. Based on the results of the independent samples t-test, the null hypothesis was rejected. All right. If the p-value is less than 0.05 of the statistical test, you reject the null hypothesis. You reject, you throw it out, because the null hypothesis says there is no difference between the two groups. So if there is a difference, you have to reject it. If the p-value is 0.05 or greater, you fail to reject the null hypothesis. You fail to reject the null hypothesis. Okay? So that's the last thing you're going to talk about. Now, let me show you what this table is, and you're going to get this as well. Let me just create page break so we can see this. So now, the table, we have, this is an APA table. So here we've got females, and we've got males, and then we've got the mean and standard deviation for both males and females. And then we've got the actual education level, okay? Then we've got the actual education level. Now, this is simply how you write it. This is what you do with the table, and that's essentially it, okay? So you have this table here. So you've got females, it's centered. You got the male and standard mean and standard deviation. You got the same thing over here. Okay. And that's the way you do it. Now, what you're going to do for tonight's assignment, you're going to run a t-test, and you're going to run it on this data. Workshop. You're going to run it on this data. So you're going to get something, a folder that says Day 1 Workshop Practice. And you're going to run it. So, and this folder is going to have an effect size calculator. It's going to have a template for an APA report, and it's going to have a data file that's called EX4. And what you're going to do is you're going to open this data file, and you're going to run the analysis. Okay? I'm not going to tell you what's what. You just have to figure it out. Okay? So you're going to take this data and you're going to run the independent samples t-test on the data. And then tomorrow, first thing, we're going to review these results to make sure that you've done it correctly. Okay? So we've got two variables. You figure out which one is the categorical variable, which one is the measurement variable, independent variable, dependent variable, and how you're going to run it, and then how you're going to write the results. And then you're going to use this same template, and you're going to fill in all the information. You're going to write this information based on that information, and then we're going to go over it tomorrow. Okay? We're going to go over it tomorrow, and then to see how you did. All right? So that's essentially it. Does anyone have any questions? Okay. If you have any questions, type in a 1. If you don't have any questions, type in a 0. Are you going to send the template? Yes, I'm going to send all this. I'm going to send you all the files, and I'm also going to send you a replay of this this session today. Okay? So once you receive the email, please reply and say receive so that I know that you received it. Because if I don't get an email that says you received it, then I'm going to assume that you didn't receive it, and I'm just going to have to figure out another way to send it. Okay, so expect this. The video is going to take about, it usually takes about an hour and a half to finalize, and then I have to upload it to YouTube, and then so it should probably be, matter of fact, let me stop it right now.